So here we're up on the top of the roof, and we've determined that so far on this roof line we have two roof exhausts. We have approximately a 1x1 roof exhaust. It could be for a bathroom, could be for a kitchen area that's exhausting, and a 2x2. From here, what we're going to do is we're going to scan the rest of the roof, determine how many we have, the sizes, and we will equate a crack size at the top of the building here. So here we have a 2x2 unit. What we do here to rectify the issue, we would actually unscrew the screws on the side here, flip the unit back, and use a one-component polyurethane closed-cell foam to bridge the gap, and then put the unit back. But a lot of the times, a lot of these louver systems are jammed open, so we use like a WD-40 to loosen them up so that the units do open and close on demand. Again, we're on the top of the roof here, top of the chimney. Actually, we call all buildings chimneys, okay, because of stack pressures. But the detail from the curb to the flashing for the skylight is always leaky. Depending on pressure, it's very difficult today. We do have a little bit of wind pressure. It could be pushing it out because we're at the top, or mechanical systems could be pulling air in. So let's just test it and see what's happening at this detail. There we go. There, we got it going good there. So we're on this roof line here, but we do have a 3 to 4 story structure over here with a slope roof, which we're not going to get on because of safety issues. So we're in one of the other roof lines, and right now there's a roof hatch to get onto this roof line. We're just going to test it from the top end. It's best to test it while you're inside. Again, because you've got a little bit of wind pressure, it may skew your tests, but they're always pretty leaky. Let's just see what's happening here. We're getting a bit of pressure from down below. See, what happens is a lot of the times the seal, this is the weather seal here, and especially in the corners, gets degraded. And this isn't quite level, so you don't get necessarily a good seal when it's shut closed, and they don't seem to always shut the best. So we do have a system where we'll weather strip. This is actually a door set, but it's a compression seal, and we'll actually put it on the framing so the door shuts into it, and this will actually outlast this stuff here. This will take up to a 3/8 warp from season to season. So now we're in the mechanical room. We're actually just on the roof. We're at the roof hatch, and now we're actually at the roof hatch below it. What I'm going to do is I'm going to go up the ladder and test with the smoke pencil to determine where the air leakage points are. Okay. We notice here there's a bit of cobwebs, so we know that there's some air leakage from just looking at the hatch from down below here. So we'll go up and take a look. So we're in a mechanical room. We've determined that we want to compartmentalize this from the rest of the building. Reason being is outside you have ventilation. You actually have an open vent on the side of the wall pulling in air for the combustion appliances up here for heating, cooling, that sort of thing. So in the meantime, what we want to do is any chaseway, the doorway that we came up through, we want to seal it to make sure that conditioned air isn't transferring up through here, or outside air isn't actually coming in from the outside and getting into where we're heating or cooling the area. So here's a chaseway. There's 2 conduits going through this chaseway, and we'll smoke puff it, and you can see that we've got some stack pressures going. So the smoke was going up. It's pulling the conditioned air from down below up into this room here, which we really don't want any of that connection whatsoever. So to rectify this issue here is we actually will stuff it with some sort of material, or foam, I should say, a 2-part foam, or even a 1-part gun foam, and then a fire caulk material over it. Because this is a rated room, we need rated products in this room. So the smoke is coming up, but someone can open a door on the other side of the building and the smoke will actually go back down in, so it's pulling the air. It's pulling the air from here back down into the conditioned space. So we want it totally compartmentalized, and there we go. We've got a change of pressure, and now the smoke is going back in. Okay, again, we're in the mechanical room here. We're making the floor part of this is our air barrier, okay? So everything above we're treating as outside the conditioned space. So here we have a duct that's penetrating through, and around the sleeve is gaps and cracks around it. You can see a little bit of air movement at this point. Underneath the sleeve, slight air movement. The taller the building, the greater stack pressures, and you know, since we have outside temperature is almost identical to inside temperature at this point, so we're not getting as much stack pressures as we thought, but we are getting some air movement here. And what we're going to do is we're going to caulk the sleeve on the top and the bottom to create the air barrier. The main thing is we're getting underneath this, we're getting close to the duct as possible, and we're making this part of the air barrier by tying it in together. Okay, so now we're at a roof wall intersection. We're fortunate enough to be in a storage room where there's no drop ceiling. Normally when there's a drop ceiling we have to move a tile to gain access to this detail here. So what we're going to do right now is we're going to test it with our smoke pencil and see what happens. So now we're at the top of the building here in a stairwell, 5th floor. On the other side of the door is actually a mechanical room, and we're just testing the stack pressures with a smoke pencil. So you can see the smoke going underneath. Since we're at the top of the stack, you know, chimney effect, the smoke is being sucked out to the outside here. And there's quite a bit of pressure here. So let's just check the door here, and well, as you can see in the door frame, all the dirt from down below is being pulled up through the stack and is being caught on the lip of the door system here. Anytime you see dirt on the lip is a good indication that air leakage is occurring. Or if you see cobwebs in the corner, because spiders will spread their webs in air paths to catch their prey. Sort of thing. So to rectify that issue, what we do is we'll use a compression seal door set, and it'll sit on the door, the side of the door here, and the door will close into it and create a 25 to 30% compression. If you did install it and compressed it right across, it wouldn't actually fluctuate with the warping of the door from season to season, temperature and moisture, humidity, and whatnot. So that's on the 3 sides, so that the 2 sides and the top. And on the bottom, what we use is a door bottom sweep. And this is a polypropylene product with a double fin. And the fin acts like a moisture and an air barrier at the same time. So this is installed down at the bottom here. And it's compressed just enough that you hear the whooshing of the fin to create that seal. And of course that goes all the way across. And we'd put it on the opposite side of the door, in essence. Here's another area of concern, fire hose cabinets. This is a plumbing shaft that leads floor to floor. So what we try to do is we try to tie in the wall to the shaft itself by sealing the cracks, gaps, and holes around it. We'll even caulk around the trim here. But let's test it, see which way the air is going. So here, you know, the gap around here. There we go. Actually, that's quite dramatic. And it should be. We're at the top of the stack here. Stack pressures are the greatest. We're on the plumbing. And a lot of the times you don't even have the escutcheon around here. It's just open. So you have an inch gap around the whole perimeter of that. You also have screw holes, the seams, and the latch itself on the opposite side. It's the same as this side here, but we've got a lot of pressure going on here. It's really shooting out. And we'll do this floor to floor. So what we're doing is we're compartmentalizing this shaft so it's not pulling or pushing conditioned air from each floor. So we're at the top of the building, where normally what we're looking at is a roof wall intersection, where roof and wall supposed to meet, but they never do. So in this case here, we're looking at the above the window system. And there has been a problem in this building apparently. Apparently they've had ice issues on the opposite side here. There's a soffit overhang over here. And by pulling down the window system here, you can see the fiberglass bats in place. And the fiberglass bats are actually quite dirty at this point. And also you can see a cobweb here. So we know that this is an air path area. But when we did pull this down just now, you can actually look right into the soffit area. So this is on the outside of the conditioned space where cold air is coming in through, or warm air is expelling through this area and melting the snow on the roof line. So we'll just smoke puff it. Right now we have some outside air being blown in. Normally, because we're at the top of the building, the air should be going out if stack pressures were working properly. But we also have mechanical pressures and a bit of wind pressure here. So the air is actually coming back in at us. So if the client decides to go with, with us doing this air sealing work, we'd actually have them take the light system out and we create a block from this wall that goes up with a two-part foam to seal it. So there isn't a connection to the outside, and we'll stop that air movement back and forth. Okay, so now we're in an electrical room that's typical in most buildings, and a lot of the times they are stacked, one on each floor above each other, so they mimic floor to floor. So when we're into a room like this, we see a lot of pipe penetrations, conduit penetrations. These are actually areas that have to be and should be sealed and fire stopped. Okay, and none of them here we can see are fire stopped. There was some attempt at the top here to seal around with one-part foam, but that's not a fire stop material. So we're in the middle of the building now. We're on the second floor, so we're just going to see what type of stack pressures we have here. I'll just turn on my flashlight and get down here and see. Let's see. Okay, so now we have movement going down. Somebody's opened a door or changed pressures, and now we have some really good pressures here. So this is an area here. It's very large, so what we'd want to do here is we'd want to stuff it with a conventional fiberglass bat or something like that as a stopper, then use the foam. The bat is used as a backer, and then a fire stop material on top. And the whole concept is if some of the fire stop material, for instance, if it's a cementitious mortar that we're using and it cracks over time, at least you have the foam behind it as a sealant, as an air seal. So if there is fire, smoke won't travel through and, that sort of thing. So same with over here where we have the wires coming through. We'd seal in around that and around the pipes here. So we have several holes to seal. There are a few different sealants that we use, so if the client actually is putting a new system in, they can pull it aside, put their wires in, push this material back, form fit around it. So there's multiple use products that we'd use in here. So now we're in a typical washroom area where we have a plumbing stack behind the wall here. The plumbers actually love to make large holes, and they cover their holes with what you call escutcheons. And you probably notice the escutcheons are getting larger and larger. But we're going to pull this back here a little bit and puff. And here you can see the smoke being pulled right into the shaft behind. Now it'll switch back and forth depending on pressures. We are in the center of the building, of the height of the building, so we do get mixed, pressure differences here. So there we go. It's being pulled in. So in a bathroom like this, we'd have, of course, 3 plumbing stacks here. For the toilets, we have another 3. And in the sinks, there's 3 per sink, and there's 3 sinks here. So we have 15 holes leading into a shaft behind the wall. Besides the paper towel holder, that actually is an insert that's part of a stack behind it. And we'll smoke puff that later to show you. Now we're at an entry door system. This is actually a commercial door system because it's mostly glass, okay? There's some weather stripping on here, but a lot of the times the weather strip has degraded, or there's no weather strip. Actually, you can tell there's nothing on there right now. But we'll check the bottom out here first. There we go. You can actually see light underneath here. And since the building is pressurized, We've got air conditioning being pushed through here. It's pushing our smoke underneath the door. We'll test the corners. The corners degrade. Now you can see the cobweb here. There we go. You can see the smoke going outside. And where they used to have a door opener, they left the holes here, and this is another air path. And we have ways of sealing this up very easily. And here at the top of the frame, the corners. And in behind the holder here.